So let's continue with the next example, the example 8 in Limtreboka. This one is a curved beam with a length of 20 meters, resembles a little bit the last example we had, and the opening in the apex with the radius is 9 degrees. So if we just go through the example, continuing here to the next slide, there are some special checks we need to be done, and the check which is concerning the apex is this one, 5,900 millimeters length. So we are just going to open the Maple sheet and the ultimate limit states, opening the example in the ULS folder, example 8. I've already opened it here. So in this case, the section of the profile is the same over the whole length of the beam, so we can in fact calculate all necessary points with one calculation in that case. GL30C, service class 2, short time, low duration, and we do have a buckling length in the strong axis grid direction by 20 meters, which is the whole length. But all the other values are restricted to 0.6 meters, so there's no buckling of the weak axis and no lateral torsional buckling in either length. So let's just look at the other values here. We don't have the continuous and discrete supports because if you go back to the example, on this page we see that there is an inclined support on the left hand side with an angle, 9 degrees angles. So let's just go back. We don't have that one, but we do have compression at an angle to the crane, and an 80 degrees arc correction. And we do have, we'll have a look at that one a little bit later. We have the curved beam definition, which is visible here. So you have these values which need to be entered. We have the 18 meter radius on the inside, or to the inside of the connection. We have the curve length 5.9 meters, and we have the thickness of the lamination of 44 millimeters. So end notch beams we don't have either, so this one is not active. So let's just check the 3 points we need to check. We have the middle of the section, the moment, which is 1235 kilonewton meters. That would be the first check here. And this one is, the result of this one is 6.4.3 double tapered curved to pitched cambered beam with an utilization of 1.53. The values here are again with the stability is not so important here as this one is already restricted, but we do have the values which are necessary for the other calculation, which are shown here. The check, of course, is done according to the Euro code, so let's just check that one. The curved beam is the checkpoint 6.5.3, and you have the formula for this check is done in this section. So let's just go back. We have 1.53 here, and the next check is at the shear check on the left hand side, 247 kilonewtons with a 90 degree. No, this one doesn't apply here because the VYD the alpha angle is just applies to the FD value. So the shear check is 0.5, and then we have the hoop leg, which is the left hand side. This has an 80-degree angle to perpendicular to the grain, or from the grain direction. So it's not really perpendicular, it's 10 degrees less than the perpendicular. So here we have 247 kilonewtons as a force, so in that case the alpha angle is actually active. So in that case we do have the check according to 6.2.2, compression strength at an angle to the grain, which in that case is 0.91, and the only values which are yellow here are those, KC90, and the compression stresses at an angle to the grain. In that case are these values to be checked by yourself. So let's just go back to the example once again. As I said, the Limtreboka has a little bit strange layout where the calculation is on the right hand side and the example and the graphics on the left hand side. So again, 20 meter span, 2 by 10 meters, and the 1240 kilonewton meters are in the middle with 247 kilonewton. This should actually be here as the supports. Calculations on the right side again. The special checks as for the tension in the apex, which is done here, the calculation. So that was a very quick summary of what we can do with the NODEMaple for this kind of constructions, and we are going to continue with the ULS in the next